In order to build an energy efficient house, you have to have everybody together, really from design stage through to completion. So with regulatory changes that are coming, we're already ahead of the curve here at Think Bright, but we just, as I said, same with our crew, want to keep reinforcing the messaging about what we build and why we build it that way. And we rely very heavily on our trades to make a significant part of that happen.
Really with the trades, it's about the air-tightness. When they come in and drill holes for their mechanical systems, we need to know where they're drilling and how we're going to seal it up later. So we talk about it.
As far as increasing the energy efficiency of a home, at construction phase, there is no question that increasing air tightness is the cheapest thing. Average air tightness in the province of British Columbia is 4.5 air changes per hour. What that means is when I start to turn my fan on, which I'll do in a few minutes, all of the air will change in 1 hour 4.5 times. All right, that is miserable. KIP is averaging 1.5 in these areas. So in this house, to take it from 4.5, which is the provincial average, to 1.5 is a savings of $800, or about 40%, 30 to 40% of the energy cost just with air tightness. So yes, you are going to spend some extra time on the fellows on their labor, and they're going to use more tape, and they're going to use more acoustic sealant and more caulking and that kind of thing. But the cost is going to be marginal compared to get that same 30 or 40% savings with your windows. KIP would answer that it's probably going to cost you $10,000, whereas the labor and material for the air tightness change would be $1,000. Just totally spitting out those numbers, but you understand what I'm trying to get at. Air tightness is the cheapest way to save money. In addition, air tightness is becoming more important because our construction practices are changing. So everybody has heard that houses have to breathe, and it is true. Houses do have to breathe, but do you want to have uncontrolled air movement through your walls? Or do you want to control the air movement, keep it inside, and then put a set of lungs in, which it would be the HRV or a balanced ventilation system. So it's far more effective. And then in addition, if you have air passing through your walls, drafty, uncomfortable for the residents. But in addition, you start to have warm, moisture-laden air moving into the wall. At a certain point, it can condense when it cools down to about 8 degrees. That is the dew point typically. With a thicker wall, you've now moved the dew point into the wall. It's no longer on the outside of the wall, so moisture will start condensing inside the insulation. So as we get thicker walls, better construction practices, air tightness now becomes not just a practical good idea for comfort and money savings, but it becomes imperative so that your walls don't start to rot. I'm going to reverse the fan, pump air into the house while filling it with smoke, and everybody's going to go outside and we're going to look at where the smoke is coming out. And this is a great diagnostic tool to help us find air leaks that we weren't able to find kind of with our hands going around on the inside.
I think it went well. I think it was nice to have our crew and some of the trades that we work with on a daily basis to be here to understand why we've been asking them to change some of the practices that they do in construction. Specifically with the air tightness. It was good because it helped everybody understand where we have air loss issues and what we need to do to rectify that for the completion of the build. So I think that was really educational for everybody.